Hi and welcome back. We're on to our second sub-lecture here talking about central tendency. We're going to focus on the median. This is going to be the longest of our discussions because the median, despite sounding like being a very easy measure of central tendency to get your head around, has some aspects of it that take a little bit more time to learn how to work, particularly in complicated data sets. The median is a measure of central tendency that is appropriate to use with ordinal, interval, and ratio data. You would not want to use the median for data that are nominal or qualitative. The simple definition of the median is that it is a value that has half of the values in the data set above it and half of the values in the data set below it. We'll note here that the median itself does not have to exist in the data set. It's just a number that has half of the values in a data set above it and half below it. Statistically, what makes the median is this really important aspect. So let's take a constant, and we're going to call it MDN for now because ultimately this is going to be the median. But if we were to search for a constant that made it so that if we find every value in the data set and went through one by one and subtracted a constant from them and threw away the sign, okay, so these are absolute value bars, and they're telling us, again, you know from your summation notation work that this is implicitly telling us we're going to step through every value of x in the data set. For each one, we'll see how far is it from the constant, throw away the sign, and we'll keep doing that and add all of those unsigned deviations up. The median is the constant that minimizes the sum of the unsigned deviations about it. Any other constant will give you a larger sum. So while we'll talk about ways of calculating the median, what makes the median is it is the constant that minimizes the unsigned deviations about it. There are three ways we'll talk about getting a median, but the way that always works starts with creating a frequency distribution with cumulative relative frequency. The median class, median group, or median value is within the real limits of the first group or class or value where the cumulative relative frequency is at least 0.50. We need to think about some numbers that are going to be easier to understand when we're actually looking at a frequency distribution, but we're going to use capital L to represent the lower real limit of the category that contains the median. We're going to use capital N to represent the number of scores in the data set. Lowercase n subscripted capital L, number of scores less than the lower real limit of the category that contains the median. N sub w is the number of scores in the median class itself, that is, that fall within the real limits of the group that contains the median, and I is the interval size in our frequency distribution. This is what I lovingly refer to as the beast. It is the equation that will always accurately give you the median, even though there are sometimes there's a faster and easier way. The equation works in all situations. There are shortcuts, and it's always worth trying the shortcut first because you'll know if the shortcut's going to work or not. To use the shortcut, if there are an odd number of scores, you rank order them from high to low, find the middle value, then ask the question, are there duplicates of that value in the data set? If there are, you need to use the beast. If there aren't, you have found the median and you can continue. If there are an even number of scores in the data set, the middle two scores can be summed together and divided by 2, and you can check to see if there's duplicates of that result. If there's no more than one of those in the data set, you have found the median and you can move on. If there's 2 or more of them, you'll need to use the beast. So let's look at 3 variables, x, y, and z, and look for each on how we would find the median. We're going to find actually for x and y that the shortcuts do work, although the beast works too, and we'll use it for each. But we'll find for z that we actually have to use the beast. The shortcut is problematic. So let's talk about x here first. We're just going to pull these data out. So we've just replicated the X values here. They're sorted for us from low to high. We see from this frequency table, this is just a good old-fashioned frequency table we've known for a day or two now, that the cumulative frequency is 7, telling us the N of this data set is 7. The middle score here is halfway between the high and the low. This value, 7, has no duplicates. There's just this one. Middle score is a 7, no duplicates of 7, the median is 7. But let's also use the beast and this frequency table to calculate the median and make sure we get the same answer. We said that the first thing you do is you find the first value or category or class that has a cumulative relative frequency of at least 0.5. This is below 0.5, this is below 0.5, this is above 0.5. So 7, this bit of information in here, the median class is fitting in somewhere between the upper real limit and the lower real limit of 7. The lower real limit of this group, 6.5, gets plugged in here. Total number of values in the data set gets plugged in here. Number of values below the group that contains the median. So we know the median's in this group because this is when the cumulative relative frequency bumped up past 0.5. There are 3 scores below this lower real limit. So that 3 gets plugged in here. N sub W is asking how many scores exist in the grouping that contains the median. Between 6.5 and 7.5, there is 1 score. So we're going to plug that in here. The interval size, 6 minus 5, is 1. Grind it out. You're going to find that we get the median to be 7, just like we did using the fast way. That's how you use the beast. Let's look at this for Y. Even number of scores ranked from high to low. Find the middle 2 values, add them together and divide by 2. 7 plus 8 divided by 2, 7.5. We come back and look, are there 2 or more 7.5s? No, in fact, there's not even one. So we have a case where the median is something that's not actually in the data set, but we'd be good to go with this. Let's look at the beast and just double check. Moving from the bottom, the first cumulative relative frequency that's at least 0.5 is here. That's within this grouping of 6.5 to 7.5, so the lower real limits of the median class are 6.5. The number of values in the data set is 6. Number of scores below the group that contains the median is 2. The number within the median class is 1. Interval size, again, is 1. Cha-ching, same answer. We're feeling pretty good about life. I'm not going to address this in this video, but I would like the interested reader to think about how this cumulative relative frequency that looks like it's associated with a 7, and you would look at this and argue this means that half the values in the data set are at a 7 or below, and yet you just told me the value that gives me half the scores above and below it is 7.5, and just chew on that. Giving a lot of it away for you to think about. Really, does this 0.5 go with 7 or does it go with the upper real limit? And think about how things ended up here. All right, one more, and let's try it for Z. We have an odd number of scores, 3 above this 8, 3 below this 8. This 8 is the middle score. There are duplicates of 8. We have to use the beast here. And so we'll look at the lower real limit of the group that has the median in it. 7.5 and below only has about 43% of the scores. And then somewhere between here and here, we jump up a lot. Right? That move, somewhere in here, is the 0.5. And the whole purpose of the beast is to figure out how to spread these two counts around to make it so that we feel like we're at the 0.5 mark. It is not halfway through here. It depends on things like how many things are below it and how many are within the class. So we know it's in this grouping, lower real limit of 7.5, n is 7, the number below is 3, the number within is 2, interval size is 1, cha-ching. This says that our median is 7.75. That it's about 3/4 of the way, quarter of way down here actually, right around there. If you spread these two scores out evenly in this space, it's saying right around there you hit the 0.5 mark. This is doing something interesting, which the beast is always doing, which is assuming that the two scores between the upper real limit and the lower real limit of this group are evenly distributed through here, sort of like a big force field spread apart. That these two are spread among here, this one is spread in here, etc. That's how you would use the beast to get the median for this data set, and you'd be good. One more thing about the median. You will notice with the median that it does not care about how far away scores are from it. Here we have an x and a y and a z where the middle value is a 7. There's no duplicates. And so we're happy saying the median is a 7 here. These are very different distributions, right? And what the median does is count. The median in this case wants 3 things above it and 3 things below it. And it doesn't matter how far above or below, it just counts where are you. And that's one of the strengths and weaknesses of the median, right? It is a strength because if you don't care about outliers, the median is a really good measure of central tendency. If you do care about outliers, it's not that helpful. So, median can be used with ordinal data, right? Turns out, as we'll see next time, the mean cannot. It is less sensitive to outliers than the mean. That is handy. It's fairly easy to conceptualize. I know the beast is nasty, but really thinking about I'm looking for a point where half the scores are above me and below me, the median is pretty easy to think about. It does not have very many weaknesses when describing samples or populations. It is a beautiful descriptive statistic. We tend to talk about the mean more because sample means are better estimates of population means than medians are. That is, sample medians are not as useful in terms of thinking about what population medians would be as compared to means. And there's some other issues that are going to come up with measures of variability and thinking inferentially where the mean is very helpful. But if you just want to describe a data set, a lot of us are very happy seeing a median. And so as I mentioned, it's true that when it comes to inferential statistics, we'll be moving away from the median and thinking the mean. Next time we'll talk about that beautiful thing, the mean. I really appreciate your listening and watching. See you later.